We are going to talk about the combined gas law. Now, it's very rare that when you're dealing with gases, you're only dealing with two of the four properties. So the combined gas law is a very useful gas law. So what it does is it combines pressure, volume, and temperature to get the following equation. We have P1 V1 over T1 is equal to P2 V2 over T2. Essentially, we are combining two gas laws to get this gas law. So let's look at an example of this. If a balloon at 22.5 degrees Celsius, this variable, this is my T1, and 0.997 atmospheres, we're starting out, so this will be my P1, has a volume of 13.7 liters. This will be my V1. At what temperature, this is my T2, will the volume be 12.9 liters? This is going to be my V2 at a pressure of 0.899 atmospheres. This is going to be my P2. So I can list out all of my variables. T1 is going to be 22.5 degrees Celsius, but remember, this has to be in Kelvin. So we're going to have to change this to Kelvin. And we can do that by adding 273. Go ahead and plug that into your calculators. We have 22.5 plus 273. And I get 295.5 Kelvin. My P1 is 0.997 atmospheres, and my V1 is 13.7 liters. Now my T2 is what we're solving for. T2 is 0.899 atmospheres, and V2 is 12.9 liters. Now, since we're dealing with three different variables, three different properties, I can't say that if I increase my pressure, this is what's going to happen to temperature because we have more things that are being manipulated. So I can use my combined gas law to solve for T2. So T2 is going to be equal to T2 times V2 times T1 divided by T1 times V1. Now we have our plug and chug situation. So I can plug all of my variables in. My P2 is 0.899 atmospheres. V2 is 13.7 liters. Man, I'm really running out of room here, aren't I? Let's see if we can move it down here. Here we go. And my T1 is 295.5 Kelvin. I'm going to divide that by my P1, which is 0.997 atmospheres, times my V1, which is 13.7 liters. And hopefully you all noticed that I accidentally put my V1 for my V2. So we can just change that. It should be 12.9 liters. All right, go ahead and do that math on your calculator. What you want to do is multiply everything across the top. So 0.899 times 12.9 times 295.5. And then I can divide that by everything on the bottom, 0.997 times 13.7. And I get a final temperature of 251 Kelvin. Here is another example of the combined gas law that you can do. When you get an answer, email it to me. If you are correct, I will give you extra credit.